Bubble formation on mixing of solvents can lead to a number of problems in HPLC analysis, which can be prevented by degassing of the mobile phase. Unstable and noisy baselines. Lower flow rate precision of pump due to cavitation in piston chamber or effect on check valve performance. Excessive pressure can develop, which can lead to eventual pump failure. Air bubbles passing through detectors lead to spurious peaks. Air bubbles can contribute to the flow transfer of the mobile phase through the HPLC column due to the creation of dead volumes. Before a discussion on the features of degassing techniques, let's understand how the problem arises. Solvents equilibrate with atmospheric gases on exposure to the laboratory environment. On mixing the solvents, the solubility of air is less than it is in the same proportion of pure solvents, and excess air will tend to bubble out. Outgassing can occur on mixing or anywhere in the LC system where rough surfaces produce nucleation sites for bubble formation. Practically, it is not necessary to remove the entire dissolved air, but only a fraction can be removed to bring it below the supersaturation level in the mobile phase. Low-pressure mixing systems are more prone to bubble formation. In low pressure, mixing the solvents are mixed at atmospheric pressure, and outgassing can take place anywhere down the flow path. On the other hand, in high-pressure mixing solvent are blended after passing through the pumps, and mixing takes place under high pressure in the mixing chamber. The mixture may be saturated, but under elevated pressure outgassing is prevented. Bubble formation, if any, can take place when the mobile phase exits the column and returns to atmospheric pressure. Degassing techniques. Commonly used degassing practices for HPLC mobile phase are helium purging, vacuum degassing, sonication. Boiling is the most effective technique to get rid of dissolved air completely, but it is never advised because of loss of volatile components along with the gases, and also it takes a long time to equilibrate the mobile phase to the required ambient temperature conditions. Helium purging removes up to 80% of dissolved air. For organic, the aqueous mobile phase, an equal volume of helium for purging is adequate. The rate of supply of helium can be reduced after some time, as excessive purging can lead to the loss of more volatile mobile phase components. Vacuum degassing removes more than 60% of dissolved air. One option is to apply a vacuum during the filtration of the mobile phase through a 0.45 or 0.22 micrometers porosity membrane filter. Online vacuum degassing is available on most commercially available systems. The mobile phase is passed through porous polymer tubing placed in a vacuum chamber inside the HPLC. The porosity of the tubing allows the expulsion of gases through the walls, but the liquid is retained in the tubing. Sonication using ultrasonic baths is common in most laboratories, but as a standalone technique, it removes only up to 30% dissolved air, so sonication in combination with any other technique is recommended. For practical purposes, it is advisable to degas mobile phase in both low and high pressure mixing systems, and a combination of different techniques can eliminate most of the problems associated with bubble formation. As online vacuum degassing is offered on most commercially available systems, sonication in combination with online degassing gives satisfactory results.